Will it split? Continuous earthquakes and the supervolcano question. Steamboat geysers roar, the rising ground, and the deep tremor mystery beneath Yellowstone. Yellowstone National Park has always been a land of fire and steam, a landscape sculpted by one of the largest active volcanic systems on Earth. But in recent months, the region has entered a new, unsettling phase. Earthquake swarms have multiplied. Fine tremors ripple across the caldera day and night. In the Norris Geyser Basin, sensors record faint, rhythmic pulses coming from deep below. And then, in the middle of it all, Steamboat Geyser, the world's tallest active geyser, has erupted again, this time with unusual force. To visitors, it feels like nature is whispering a warning. To scientists, it feels like an urgent puzzle. A pulse beneath the caldera, the continuous earthquake problem. The first alarm began with a sudden rise in micro-earthquakes, tiny quakes often too small to feel, but easily detected by seismic networks. Normally, Yellowstone experiences thousands of these per year, but not like this. Over a span of several weeks, the number of quakes surged dramatically. At one point, more than 400 earthquakes rattled the region in a single 48-hour period. Then, as the swarm seemed to settle down, a new cluster ignited just a few kilometers away. This pattern repeated popping up, migrating, pausing, then resuming again. Seismologists call this behavior episodic swarm migration, a term that sounds benign but suggests complex movement of fluids or pressure waves in the crust. What's moving down there? Beneath Yellowstone lies a sequence of layers, shallow hydrothermal systems filled with boiling water and steam, porous hot rock fractured by ancient eruptions, a partially molten magma reservoir containing pockets of melt, a deeper, hotter magma body originating from Earth's mantle. When the pressure changes, fractures crack, fluids shift, and the entire region reacts. Many scientists believe the current swarms may be the surface expression of deep fluid migration, possibly superheated water or volatile gases leaking upward from the magma system. But the biggest question remains, are these quakes harmless stress adjustments or the early signs of a system being recharged? Steamboat Geyser, the giant that won't stay quiet. In the midst of the seismic uptick, Steamboat Geyser delivered one of its most powerful eruptions of the year. Visitors reported a deafening roar, a column of water shooting over 300 feet into the sky, and a shockwave that rattled nearby observation platforms. Steam drifted across the basin for hours afterward. Steamboat has always been unpredictable, sometimes quiet for decades, sometimes erupting dozens of times a year. But recently, scientists noticed a pattern. Many of Steamboat's eruptions line up closely with earthquake swarms beneath Norris Geyser Basin. Not perfectly, not every time, but often enough to raise eyebrows. What's the connection? Steamboat's plumbing system is deeply rooted deeper than Old Faithful or most other geysers. It taps into regions where boiling water mingles with rising gases, making it incredibly sensitive to pressure changes. Continuous earthquakes might be opening new cracks, pressurizing water chambers, forcing superheated water upward, or allowing new pulses of heat to reach shallow depths. In other words, Steamboat's violent eruptions could be the surface echo of deeper unrest. Will it split? A question scientists are quietly debating. One of the most dramatic geological threats in Yellowstone is the possibility of a sudden rupture in the caldera floor. It wouldn't be a global catastrophe, not a super eruption, but it could trigger a devastating hydrothermal explosion. Hydrothermal blasts are violent, steam-driven eruptions capable of hurling rock, mud, and boiling water hundreds of meters. They have happened many times in Yellowstone's past and have left impact craters still visible today. The current pattern, continuous microquakes, plus steamboat activity, plus localized uplift, fits the rough profile seen before past hydrothermal events. Scientists quietly ask, is pressure building beneath a sealed layer of rock? Is the ground preparing to crack? Could a chamber of superheated water be approaching the boiling point of instability? Sensors near Norris have detected tiny bursts of gas and sudden steam surges, potential hints of deeper fractures forming. For now, the system remains stable, but the ingredients are present. Is a supervolcano awakening? The real answer is more complicated. Despite the dramatic headlines that Yellowstone attracts, scientists are not predicting a super eruption. There are no signs of massive magma input, rapid ground deformation on a caldera-wide scale, huge gas releases, large magnitude seismic events. Instead, what's happening looks more like a repressurization of the hydrothermal and upper crustal system, the kind of process that can last years or decades. However, continuous earthquakes matter. They show that the ground is responding to internal changes. They show fluids are moving. They show stresses are reorganizing. Some models even suggest that persistent swarm activity can gradually weaken crustal boundaries, allowing magma or pressurized water to rise more easily, raising the long-term probability of future eruptions. Small or large, the question isn't will Yellowstone erupt now? It's what is this unrest building towards slowly, quietly, inevitably? The future of this unrest. What happens if it continues? If the current pattern goes on for months or years, several outcomes become plausible. 1. A large hydrothermal explosion, the most likely. A sudden rupture could unleash an explosion equivalent to a small volcanic blast, forming a crater and sending steam and debris skyward. 2. A new geyser or hot spring opening. Fractures could redirect hot water to the surface, creating new hydrothermal features. 3. A small magmatic eruption. Still unlikely, but possible. If magma is slowly rising through the crust, this would produce lava flows or ash in a localized area. Serious but not apocalyptic. 4. A major geyser basin reorganization. Continuous quakes could rearrange underground plumbing, causing geysers to die, awaken, or relocate. 5. A surge in steamboat activity. Steamboat could enter a new phase of hyper-eruptive behavior, becoming more powerful and more frequent. Is Yellowstone splitting open? Not yet, but it's changing. But the scientists monitoring Yellowstone emphasize caution, not panic. But they also acknowledge that the region is shifting subtly, steadily, and unmistakably. The ground is breathing. The quakes are whispering. The geysers are answering. Something is happening beneath Yellowstone, even if it's not the end of the world scenario imagined in movies. For now, the story continues a slow, deep, rumbling mystery. And the world watches a landscape shaped by fire, waiting to see where the next crack will appear.